Lesson 9.4 is radians on the clock. You might see this, who knows? It's pretty simple once you figure out what you're doing. So I've got a blank clock here. Let's just say I want you to make the time 3 o'clock, and I'm going to go ahead and extend the hour hand all the way here and here. Okay, picture this as a unit circle. And so when it's talking about radians, we know that a complete revolution is 2 pi. We know that a 180 over here at the 9 would be our pi. We know that up here would be our half a pi, or pi over 2. We know that down here would be our 1.5 pi, or 3 pi over 2. Okay, so that kind of gives us a reference point. So if I asked you, what's the radian measure of the angle formed at 3 o'clock? That would be this right angle right here, which is 90 degrees, or pi over 2. Right? We know those things are equal. What's going to help us more, though, is knowing what each number is. So let's say now I broke this up into, I'm going to go to this 2 here. So I know this is not a good time to tell, but we're going to go between the 2 and the 3 and figure out what is this wedge right here in radians or degrees first. So look, this is our starting or initial ray we've talked about. This would be our 30. This would be our 60 and our 90. So each little wedge here between these two consecutive numbers is 30 degrees. Well, 30 degrees out of 180 degrees is 1/6. So pi over 6. So it's really good to know that between each number is going to be a pi over 6. So let's look at number 1. What is the positive radian measure of the smaller angle formed by the hands of a clock at 5 o'clock? So I'm going to make 5 o'clock here. And you're not going to have these clocks. You're going to have to sketch them out or think of it in your head. The smaller angle. So the smaller angle is this right here. This would be the larger angle on this side. So we want to figure out what is this in radians. So you could find degrees first and then change it, or I'm just going to go on and think, okay, between every one of these, so here to here, 5 to 4, that's a pi over 6. 4 to 3 is a pi over 6. 2 to 3 is a pi over 6. 2 to 1 is pi over 6. And 1 to 12 is pi over 6. So how many pi over 6 are there? 1, 2, 3, 4, 5. There's 5 pi over 6's. 5 times pi over 6 is 5 pi over 6. Kind of cool. Or that would be 30, 60, 90, 120, 150 degrees. If I replaced pi with 180 degrees, it's 150 degrees, like I said. All right, and then number 2, what is the positive radian measure of the larger angle formed by the hands of a clock at 2 o'clock? So I'll make my 2 o'clock here. The larger angle would actually be around this way. Okay, so how many pi over 6's do I have? There would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 pi over 6's. Or 10 pi over 6, or cross simplify first, divide out of 2, that would be 5/3. So 5 pi over 3. And again, you could find degrees and then change it into radians if you would prefer.